In this video, what we're going to do is we're going to discuss how different types of graphs can be misleading. Recall back when we were discussing the different types of sampling and how our data can contain bias. Well, our graphs can also contain bias. The first way that graphs can contain bias is our vertical scale, right here. When we're talking about the vertical scale, what we want to do is we want to make sure that we always start at 0. If you'll recall, whenever we did the time series, I did say that you could have a break here. The only thing is if you have that break, make sure that you're consistent on where the break is, especially if you have multiple sets of data that you're looking at. Each data set where you're looking at the graphs, they need to have the same break and the same type of scale. Notice this one, we're counting by 5s. Here, we're counting by 1s, but we didn't start at 0. So in all honesty, these number of passengers at Denver International Airport for the different years, there's not a huge difference. Whereas if you look at this graph over here, there seems to be a major difference. If you just glance at these two graphs, the one on the right suggests that there's major differences. The one on the left suggests they're actually approximately the same. This data is the exact same for both graphs. The difference is the fact that this graph does not start at 0 and counts by 1s, whereas this graph counts by 5s, which is okay, but it does start at 0. So it's showing you that all of this is still the number of passengers. Because right here it looks like 2006 had very few passengers. Well, in all honesty, they probably had about 47.2 million passengers. That's still quite a few, and they're not showing up on this graph. Same thing happens with line graphs. Here, you notice that it looks like there's a drastic decrease, drastic increase, that type of thing. Where in all actuality, they basically are all approximately the same. Now, I do realize that between 47 million and 51 million, there is a huge matter, but we're also talking about millions here, okay? So one note here is that we need to start our scales must start at 0. Otherwise, they're going to be misleading. Okay? Another type of misleading graph that we see quite often is what we call the area principle. When you are comparing amounts, make sure that the width of your bar are proportional to the height. Okay? Notice on this one, the cost of jet fuel, my bars are the same width. I want to be consistent. The heights are different, yes. Now if I look at the height of this bar, let's say that that's 75 cents to about $3.75 difference, okay? And then if you look at the graphics here, 2003 to 2013, they need to be proportional to the size, to the height of our graphs. Another thing that we need to look at is whenever we're looking at pie charts, you have to be careful because of the fact that this one, you can't see a lot of it, okay? Because this piece right here looks massively larger than this green piece or this purple piece, because we're seeing the side of the pie as well. Think about when you look at something through a bottle or through a glass pitcher or anything, it's distorted. Well, this type of graph is also distorted. This is a pie chart that is actually not misleading because of the fact you see each piece representing its value correctly. When we talk about graphs and misleading data and everything, we have some guidelines that we want to make sure that we follow. The first is title and label the graphic axes clearly. You've heard me talk about that in the other videos. Make sure that you are labeling them appropriate, not just class limit, class midpoint. Describe what the data represents. You include units. You've seen me include seconds, millions, thousands, that type of thing. Avoid what we call distortion. In other words, never lie about your data. If your data is skewed, your data is skewed. If you have an outlier, you have an outlier. Okay? We want to minimize the amount of white space in a graph. Use the available space to let the data stand out. If scales are truncated, be sure to clearly indicate this to the reader. That means do that little break. You've truncated it. Okay? Avoid clutter, such as excessive grid lines, unnecessary background, or pictures. For example, you've seen many graphs that had, especially on our XY axes, you've seen them more like a grid line, so that you can place a dot. That actually is very distracting. For one reason, if it's printed just in black and white or in the same colors, I can't tell the difference between this point, this line, this line. I don't actually see where my data is. So I want to get rid of that white space there and just keep my dots. And if it's a line graph, I'm going to connect those dots. Avoid 3 dimensions, such as this one right here. It's very misleading, so we want to avoid those. Do not use more than one design in the same graphic. Sometimes graphics use a different design in one portion of the graph to draw attention to it. We don't want when we are presenting a graph, we don't want to point things out. We want to let the data speak for itself. Therefore, you just want to put the data up there and back away. Don't put one bar in one color, another bar in another color, anything of that nature. The heights of the bars are going to speak for themselves. Okay? Avoid relative graphs that are devoid of data or scales. Meaning, don't just put a graph here without any explanation, the graphics. Make sure that you have your scales labeled so that the reader, the person looking at the graph, can identify what you're discussing. So these are just some tips on how to construct good graphics. So read over those and see what might be misleading. Go to the newspaper or website and see, do you see anything that could be misleading there? And then let me know if you have any questions.